Pydantic AI's agent runtime exposes a lifecycle of model requests, tool calls, and output processing through a single interception mechanism. The hooks capability, which registers decorator-based hooks at named stages such as before model request, to observe or modify the messages flowing to the model before each LLM call. The following code demonstrates initializing a hooks instance, attaching a logging hook via @hooksOnBeforeModelRequest that prints the message count, and passing that capability to an agent that runs a single synchronous prompt, with the hook returning the unchanged model request context, so the request proceeds as normal. From Pydantic AI import agent, model request context, run context. From Pydantic AI, capabilities import hooks. Hooks equals hooks. Hooks on before model request. Async def log request dex. Run context none, request context. Model request context, model request context. Print sending len request context. Messages to the model. Sending one messages to the model. Return request context. Agent agentist. Capabilities equals hooks. Result equals agent. Run sync hello. Print result, output. Success no tool calls. The code registers a before model request hook on a hooks capability, passing it to an agent so the hook fires on every LLM request. The hook receives run context and model request context, accesses request context messages to log the count, then returns the unchanged context, the simplest possible interception pattern. This is the recommended way to add lifecycle concerns like logging or metrics without subclassing abstract capability. Hooks compose cleanly since multiple can register for the same event, firing in registration order, and the hooks capability keeps application-level interceptors separate from reusable tool instruction bundles. Let's break it down. From Pydantic AI import agent, model request context, run context. From Pydantic AI, capabilities import hooks. Imports agent, model request context, and run context from Pydantic AI for agent construction and context management, plus hooks from Pydantic AI, capabilities for lifecycle hook registration. Hooks equals hooks. Creates a hooks instance and assigns it to the variable hooks. Hooks on before model request. Async def log request dex. Run context none, request context. Model request context, model request context. Print sending len request context. Messages to the model. Registers a before model request hook that prints the number of messages being sent to the model. The hook receives the current run context and request context as parameters. Return request context. Returns the request context object to the caller, exiting the current function. Agent agentist. Capabilities equals hooks. Result equals agent. Run sync hello. Creates an agent named test with hooks capability attached, then runs it synchronously with the prompt hello, and captures the result. That's the whole pattern. Hooks gives you a single interception point across the agent lifecycle. Here it's just before each model request, and the decorator wiring keeps it declarative. The log request hook receives run context and model request context, peeks at the message count, returns the context unchanged, so nothing is altered. Multiple hooks can stack on the same event and fire in registration order, which is what makes them compose cleanly without subclassing abstract capability. The key design move is that this lifecycle concern stays in a separate hooks capability, leaving the agent itself focused on running requests.
The hook intercepts the request before the model speaks and counts every message still arriving.